Hi, everybody. Thanks for coming. And like I said, I'm Mike Becker. I'm Director of Big Data and Business Services at RingCentral. And this is Varun Narantar. I had to practice his name several times on the way here. Even though he works for me, we sit right next to each other. I usually just call him Varun, so that's why. So go ahead. So we're here today. We're going to talk a little bit about, first of all, RingCentral. So you know we're all in the sales mode all the time, right? So we want you to know about RingCentral. And then I'm going to talk about data services and how RingCentral implements data services. And then I'm going to talk a lot about quality of service, and that's about the quality of our phone calls and how we measure that. And then Varun's going to give us a really cool presentation on scaling out StreamSets. And then after that, if you guys have any questions, we'll be happy to answer them. So go ahead, Varun. So first of all, RingCentral. RingCentral is the largest and fastest growing pure play UCaaS provider in the world. And UCaaS is Unified Communication as a Service. Our product is composed of really 5 different products. First is our telephony, which is our core product in which we've based all of our business on in the past. And then we've expanded. Now we have what's called Glip, which is a collaboration software very comparable to something like Slack. We have call center software called Contact Center. We have, let's see here, 1, 2, 3, 4. We have our video conferencing, which is really good and one of the highest quality video conferencing services on the market. And then we also provide what's called API. And API is really interesting because what our API product allows you to do is to build your own products using our components. And I'd like to give a really good example is our integration with Salesforce. As everybody here is probably very familiar with Salesforce. And Salesforce integration with RingCentral works like this. I'm a sales rep. I'm in my Salesforce application, and I see a lead that I want to talk to. I click on the phone number within Salesforce, and it initiates a call. I'm still in the Salesforce application. I talk to the customer through my headphone set. I keep notes on my Salesforce application, and then I discontinue the call. And I'm still in my Salesforce application. So this is very powerful, and it's being used by a lot of our customers as well as a lot of our partners who are building products based on our components. So, no, I'm not ready. I'm not ready. And so, last year, we achieved revenues of over $500 million. Our year-over-year growth rate was 32%. Right now, we host over 200 million calls a month, and we have over 350,000 customers. Next slide, please. So, in the UCaaS space, the cloud is winning. In our space, 12% downgrade in on-premise use of unified communications, and in the cloud, UCaaS has grown by 21%. Next. But guess what? RingCentral is winning in the cloud. So we are growing at a 37% rate, and we are very proud of the fact that we are achieving this growth rate in this market. And if you compare us to our competitors, next slide, everybody's growing. Remember I said 21% growth rate in the UCaaS market. So even though all of our competitors are growing, we're growing faster and we're taking down more market share. And it's showing in the results that we're getting from our various organizations that identify UCaaS providers. Next slide. So as you can see here, for the last 3 years, we've been Gartner Magic Quadrant leader. We won the Frost & Sullivan Company of the Year for the last 2 years. And IHS Markit has identified us as a leader in North America UCaaS, as well as Argonne leader in the Argonne Research Globe for unified communication. So that's great. So we're a growing company, and we have a lot of data, and we have to deal with that data. We have really focused on trying to enable the use of our data throughout the company. Next slide. And at the center is our enterprise data hub, which is based on Cloudera. And we have our products, customers, transactions, and employees. Next slide. And in the old days, we had point-to-point, predetermined data pipelines, apps on disparate networks, bottlenecked by our BI dev team who never could get the work done, and it was all historical and batch-oriented. But now, hello? It's our new, we have a diverse workload platform with an ecosystem where we curate our data. It's role-based access. We have API and web service access. It's predictive. We're using predictive analytics as well as we're having fast data. Next slide. And so it all starts with the original data. So it's historical, any source, full fidelity. And then on top of that, we generate our single source of truth using all the various tools within our company. As you can see, we used Oracle, Talon, Hadoop, Vertica, StreamSets, Kafka. And then we connect those, and you see StreamSets is one of those connectors. Now on top of that, we have several BI tools. We've built JavaScript with D3, we use Tableau, and we've built our own, what we call Data Explorer based on Metabase. And then we created these consumption pipelines, API, SQL, search. And then the goal is to really monetize this data because this data is worth a fortune, right? First of all, it costs a lot of money to put this data together, but it's worth way more than it cost us. And we're monetizing that by providing data as a service for our customers, as well as new data features within the company that help us really capitalize on our understanding of our business because of the data. All right. So I just wanted to show you like one of the latest and greatest inventions that one of our team members created. It's based on Metabase. We call it Data Explorer. And what we love about it is that it really allows our customers to do data exploration, right? It's open source. You know, we're not going to rest on our laurels. We'll continue to evaluate new offerings that are out there. And basically it allows our customers to dig in and look at the data, visualize the results, and then if they want to use SQL, they can use SQL on this platform. And so that's been a great achievement for us, and we've gotten a lot of really good feedback from our users within the company that are using it. All right, so now I'm going to talk about QoS. QoS is really interesting. It stands for quality of service. And as you can imagine, we're a telephone company, and quality is incredibly important to us. So for some of you that are maybe closer to my age, do you remember they used to have a commercial where they say you can hear a pin drop, right? Well, I don't know if you really could hear a pin drop, but at least they had pretty good quality. And we want to achieve the highest quality against our competitors that we can. And so we measure the quality of our calls. And because we're a cloud-based telephony provider, our calls are very complicated. They go over multiple systems. And we actually have 3 systems that we measure the quality of our calls. The first is our Acme, which is the gateway from our core network of our platform to the internet. And then we have our carrier partners. So if you can imagine, if I were to call you up on a RingCentral phone and I were to call you up on your cell phone, that would go through our carrier partners, so like a Verizon or an AT&T. So we have to connect to those partners, and they have their own network. And then finally, we have IoT for our phones. So our voice over IP phones provide what is called RTCP-XR. I don't really know what those stand for, but XR, RTCP. But basically what it does is it sends a MOS score back to our core network once a phone call completes from that VoIP call. So it gives us the ability to measure what the customer's experience was on that phone call. And so MOS is how we measure our calls. It's called QoS MOS score, and it stands for mean opinion score. And it goes back to the old analog days, right? Where basically they would get somebody on the phone and then they'd say, oh, I think, it's this value. And then somebody else would say the same thing, and then they take the average opinion. And that's how they determine the quality of the call. So we are able to measure that ourselves, and it ranges from 1 to 5. whereas 5 is an excellent call and 1 is a bad call. And that's really important that you understand that we're able to measure this. So it can be anywhere from 1.0 to 5.0. Usually it's somewhere in the range about 3.5 to 4.5 for our calls. And this is where it gets really interesting. So this is the QoS architecture. We spent a lot of time working on this, and I'm really excited to talk about it. So remember I talked about our core network, which is this part right here. And then I talked about our external carrier network. And then I talked about our ISP network. So, and you can see this is where our Acme switches are, and this is where our Sonos switches are. And this is where our media servers are. And these are really the switches that connect the phone calls to each other. And so each one of these boxes represents a point where we can measure the quality of the call. And so you can see here, we use Palladium to measure these 3 segments of the call. But we can measure the quality of the call through Acme on these 3 segments and Sonos on these 3 segments. And then you see down here it says RTCPXR. So at the end of the call, we can measure this segment of the call. And so we take all of these measurements and then we collect them and then we aggregate them to figure out what the quality of the call is. All right. And so this is where StreamSets comes in. And so what you can see here is I have my Kafka network with all the various systems that we've instrumented Kafka onto those systems. And then we use StreamSets to ingest the data onto our Hadoop cluster. All right? And the StreamSets instruments Spark streaming. So basically we have this Spark streaming taking all of these various systems across our Hadoop cluster in real time. And then we're using HBase to do lookups. So if you can imagine how a streaming lookup works, say that I have a phone call and I have a customer ID and I want to know more information about that customer. I can dip into HBase and I can find out all the information I want on that customer, and then I can enrich that stream in real time, right? And then so what we do is we have kind of a strategy. We have what are called an indexed UCDR, and then we have a correlated UCDR. And we're going to talk about that. And one last thing, you see here Yarn is managing all the resources on the cluster. And as you can see here, we write our real-time index UCDR to HDFS, and in real time we write the indexed UCDR to Vertica. After 12 hours, in order to reduce the amount of data that we're storing on our Vertica cluster, we correlate the calls. And I'm going to tell you what that is in a second. And then we write these correlated calls to Vertica, and we write these correlated calls to HDFS. Sure. Let me finish this sentence, and then I'll answer your question. The correlated record, it's a single record for that phone call where we take all the information from the various systems, we create a single record about that call instead of having multiple records for that call. Go on.
So Spark Streaming and Vertica, when you talk about real time, are you defining like a batch window? And so like, how do you think about batch window when you say real time?
Well, we're able to process 1,000 records in about half a second.
Okay.
I
So
consider that pretty close to real time.
Does that mean that you're updating every half second, or does that mean that you're...
Yes.
Okay.
Yeah. Okay, and so one more time. Go ahead. First of all, we index the CDRs with a common key. We load directly into CDR with multiple CDRs, into Vertica with multiple CDRs, and then we correlate that QoS record with metadata for the call generated after 12 hours. And so now I'm going to show you the secret sauce. This is really the kind of stuff that you guys want to know about. And this is how we do it. So first of all, remember I told you we're writing to Vertica and we're writing to HDFS. Well, just to be clear, we're writing to HDFS Parquet, right? And both of those systems are columnar databases, right? And so what we do is, you see here I have one record for Sonos with this QWERTY RC session ID, which is our common index. And then I write the data to Sonos columns. And then for Acme, I write the data to Acme columns, and then RTCPXR, I write to the RTCPXR columns. And basically, there's no overhead by having those empty cells because we're using columnar-based storage. So it's okay, we can do it, and it's not going to give us a lot of overhead. Then after 12 hours, we take these records and we write it to a single record, and then we have one single ID record for this call, which has that common RC session ID, as well as columns for Sonas, columns for Acme, column for RTCPXR. Any questions? All right, so with that, I'm going to hand it over to Mr. Narantar.
So we've been using StreamSets since 2016, and there are quite a few teams within our organization that use it. Primarily security operations, telco operations, so our team big data and engineering. And us specifically, we write it to HDFS and Vertica so that we can generate our QoS reports. So until now, we've been using a single node architecture where we install it on a single machine, and we get the data out of Kafka, send it to the machine where we populate the session ID, we enrich it with customer information, GeoIP information, and then write it to HDFS. But this has the average throughput of this data flow is about 150 to 300 records per second, which is not enough to the amount of calls and records that we generate. So because of this, our pipelines are too slow, and this slowness has caused a kind of loss in, we don't get all of the records, and there's loss of records due to the log rotation. Now, some of you might know, Kafka is our message queue. So what log rotation occurs is basically a queue overflow. When there are already existing records and there are new records coming in. So in order to accommodate the new ones, the existing record might be rolled over. So this had been a problem for us. So then here's an example of the single node architecture pipeline, a screenshot of the pipeline. It's a simple pipeline. We get the data, we parse it, and just directly write it to HDFS. But again, if you see, it's about 160 records per second, which is definitely not enough. So we tried to implement the new cluster mode architecture where we could use all of the data nodes available in our Hadoop infrastructure. And this would help us achieve high availability and scalability. And what we thought in a POC that the throughput can rise up to 10,000 records per second. We could write just as the records were coming in. So there would be no loss of records. And I think this is a typical cluster mode architecture where we built the pipeline on the single node, which acts as kind of an orchestration node, which bundles up all the information about the pipeline. Then it sends it to Yarn, where Yarn is like the Hadoop manager. It assigns the workers where the pipeline should be run. So as soon as the data comes out of the Kafka cluster, it's sent to these worker nodes for processing, and then directly written to Hadoop. So this is the extension of the cluster mode architecture that we plan on what Mike said earlier for the UCDR. And
let's go back to that. Let's talk about that. So what you see here is we have a cluster architecture with our Sonas network. We have a cluster architecture with our SBC, which this is Acme. Cluster with it, well, it's not really, it is kind of cluster, RTCPXR, because we have multiple nodes sending it in. And then we collapse this onto a cluster of Kafka, right? And then we use StreamSets as an orchestration node for this cluster, which is high available. And then multiple processors are processing the stream, and then onto our, so basically everything's a cluster. Like it's all cluster to cluster. There's no single node that we have a single, that we have a bottleneck on.
So it's the same pipeline that I showed earlier, running on cluster mode. And I'll show you a demo soon. So if you see here, the record throughput is at about 1,100 records per second. It's processed about 1.2 million records. And here you can see the instances of where, or the nodes where the pipeline is running in. So let me just stop it right there. And yeah, this is the same pipeline that was, I ran it yesterday. In about 21 hours, it's processed 23 million records. The throughput right now it's down. I assume that everything's that.
Everybody get out and make a phone call. Let's get that number up, right?
So everything's being written, and we can even check a particular node right here.
This is the live production.
This is live production.
Nice.
Yeah.
How do you kill a job?
And we can even go in the StreamSets Spark streaming statistics to see what the input rate has been, how much delay is there, how many batches are processed, and we can get a clearer idea here as well.
So this is the yarn, right? This is the yarn, and then we go from yarn to Spark streaming, and then this is the Spark streaming output from our Hadoop cluster. And so not only can we look at, and honestly, we spent a lot of time looking at this report versus what StreamSets was showing us to make sure that they matched, right? And now they match, and they match really well. And we're really excited about it.
So now that we know we can achieve cluster mode streaming in our pipelines, we'd like to start implementing it to all our sources. And one of the sources, like Mike said, is Acme, which we use to visualize where RingCentral calls are made globally.
Well, on
And
the Acme calls, because it's ISP, we have the IP address, right? And from the IP address, we can derive the position of where that phone call is originating.
So, and we know that there is already a GeoIP processor that's available in StreamSets, but that's, I think, for MaxMind. And we use Newstar because I think we get more granularity than MaxMind. And currently, we've been
In the past.
in the past, sorry. We're just switching over. But yeah, so we use SQLite as an enrichment source. We keep the customer information, GeoIP information in SQLite, but again, that's single-threaded. It's only good in a single node architecture, and so we've decided to use HBase as a SQLite replacement, since it's a data store that sits on top of Hadoop and it can scale horizontally. But then again, HBase is like a key value pair, key value lookup. So, and GeoIP is a range scan. So using a scan in HBase, that was significant performance degradation. It's only good with a get rather than a scan. So we tweaked our approach a little. We loaded the start IP in memory and used a binary search to get the start IP, which was then used as a key for HBase. So using this, we got a throughput of about 600 records per second, and we can send the GeoIP in memory to all the nodes and just use this for our cluster mode architecture.
So this is 600 records per second per node.
Per node, yes, exactly.
Yeah, that's right.
This is a POC that I did last quarter. It's just I've been using a dev generator just to stream as many records as I can. And let me just go back and show you the demo of this pipeline. See.
Basically using SQLite as an index on top of HBase?
No, but hey, we'd love to talk to you about it later. If you got some good ideas, we're open to those.
Yeah, so it's up for about 4 hours. I load the start IP in memory right here. And then in the binary search, I just do a simple lookup. And then we use that key to write it to look up for HBase, and here you can see whichever test fields that we get back from the HBase lookup.
Yeah, sure. So in conclusion, as you see, we've solved our GeoIP lookup using in-memory binary search combined with HBase. It's given us really nice performance. StreamSets cluster mode now allows us to massively scale. Vroom is very conservative. We can scale tens of thousands of records now, right? Because on Hadoop with the yarn, what it does is it allocates that memory and compute for each one of those little containers that it has on the Hadoop cluster. So we can run more than one container on a node. So we can really scale this out. So it allowed us to create the unified call detail record. And then because they talked about fraudulent calls, and since I've talked about it in the past, we've shown you our UCDR. But we're literally using this cluster mode now to monitor our calls real time. And what's really cool is that we have the ability to calculate how much a call costs in real time. And so what we do is we look for these calls that are really expensive and we know that they're fraudulent. And then we're using StreamSets to stream this data, and we can monitor these calls in real time. So StreamSets has given us the ability using cluster mode to do that also. So that's really exciting. All right. And then I wanted to talk about, we say here Q2, we got to talk to StreamSets about this. So, I talked a lot about cluster mode and how we have the high availability. We still have a vulnerability with our single StreamSets orchestration node. And so we're going to evaluate DPM so that we can have failover StreamSet orchestration nodes. So if we do that, then we have a completely HA pipeline because our orchestration node right now is our single point of failure. All right, that's it. Thanks, everybody.